A tree is a graph that is connected and has no cycles. An important theorem about trees is listed here. And this theorem gives two properties about trees. The first property is that if you delete an existing edge from a tree, this creates two trees. And the second property is that if you add an edge between two existing vertices in a tree, this creates a cycle. So let's see what this means. So first I'll illustrate with an example. I'm not going to prove anything. The first property that I'll illustrate is property 1. All right, to do that I need a tree. So let me draw a tree. Okay, so this is a tree, right? It's connected. It's connected, meaning that between any two vertices, there is a path. And also there are no cycles, meaning that there's no things like something like this, right? Who go around and then come back, right? There's no way to go in a roughly a circular pattern from one vertex back to itself. So it's a tree. All right, now let's delete any edge, any existing edge in this tree. So we have lots to pick from, lots of edges to pick from. Let's delete this edge right here. Okay, so let me do that. Okay, I'm going to delete this edge, boom, and look what happens. We have two trees, right? This right here is a tree. Let me circle that. So I'll circle that in green. We have that tree, right? That's a tree. And we also have this other thing. That's a tree. Now, why is this true? This is true because, remember, the original thing was a tree, meaning that it was connected and there were no cycles. So if you delete an edge from a tree, right, there isn't going to be any cycles in the two connected components or the two pieces, right? Because if there was a cycle in one of these two pieces, if there was a cycle on that piece, then there would have been a cycle in the thing that we deleted the edge from in the first place, right? Similar for this one. If there was a cycle there, then deleting the edge wouldn't have eliminated that cycle in the first place, and it wouldn't have been a tree to start with. Okay, it was connected already, right? It was connected with that edge before I deleted it. It's still each of these pieces you can see are in fact connected. Okay, so that's the idea with one. If you delete an edge, any existing edge from a tree, then you get two trees. Maybe I should delete another edge. All right, maybe I should delete that edge. Well, these are both trees. A single vertex is a tree, right? We've already talked about in previous lessons that a single vertex is connected, right? So this single vertex right here, that's connected. And does it have any cycles? Well, no, it doesn't have any cycles, so it fits the definition of being a tree. So we deleted that edge and we got two trees. We got that tree, single vertex is a tree, and we got that tree. All right, so now let's move on to, oh, I guess I should have left that tree, but anyway, let's move on to property 2. If you add an edge between two existing vertices in a tree, this creates a cycle. So I'll draw a new tree. Okay, so let me illustrate this. So adding an edge between any two existing vertices in a tree creates a cycle. All right, so which two vertices do we want to add an edge between? Well, let's say that one and that one. All right, so let's add an edge. Let me add this edge in red. So the added edge goes there. And now look, we have a cycle. Right, where's the cycle? Right, it's exactly there. That's a cycle. Let's say the two vertices that we want to add an edge between, a new edge between, is like that one and that one. Okay, we go like that, and now look, we have a cycle. We have a cycle. All right, so this shows us that part 2 is true. Okay, now what does all this mean? Big picture. All of this really tells us something important that I want to illustrate here. Okay, so let's say we have some tree. Here's a tree. And here we have disconnected. Disconnected graphs. And over here we have graphs with cycles. All right, so the point here is that we can characterize trees in this way. So in the middle, right, in this area here, we have all trees. And here I just have an example of a specific tree. But just think of it as, in this region here, we have all trees. In this region over here, we have all the disconnected graphs. Over here, we have graphs with cycles. All right, and so the idea is when you delete an edge, from a tree, you create a disconnected. You move a tree from the land of trees into the land of disconnected graphs. And when you add an edge to a tree, then you move the tree into the land of graphs with cycles. So trees are these special graphs that live in between all of the disconnected graphs and all of the graphs with cycles. Think of this, these dotted lines as like the edge. Trees are as close as you could be to being disconnected without being disconnected. If you delete an edge, all of a sudden they're disconnected. And trees are right on the edge of being a graph with a cycle. They're as close as you could be to being a graph with a cycle without actually having cycles. If you add any edges to a tree, then you create a graph with cycles. And that's the idea.